In the diagram below, DE divides AB and AC proportionally. So that statement is telling us that, yes, AD and BD here are going to share some kind of segment and will have some kind of ratio. And because DE is dividing AB and AC into proportional parts, then if AD there has a length of n, then AE would have a length of, let's say, n times k by some proportional constant. Same thing with EC there. If AD is m, then EC will be m times k, right? It will be some proportion greater. Angle C is equal to 26 degrees, angle A is equal to 82 degrees, and DF bisects angle BDE. So DF bisects angle BDE, telling us that these two angles are congruent. The measure of angle DFB is, so we're looking for angle DFB, which is this guy over here. So looking at this right now, we can justify actually that triangle ADE is similar to triangle ABC. For what reason exactly? For side angle side similarity. Now, how do I know that? I know this because both triangles are sharing angle A. Both triangles, if I compare the side lengths now, AD to, say, AB, so it will be n to m plus n. This proportion will hold true for AE to AC. So AE is nk, and AC is nk plus mk. Are these two things actually the same? Yes, as a matter of fact, because if you look at this, the denominator has a common factor of k there. So the k's will cancel, and we end up with the same proportion. We end up with n over m plus n is equal to n over m plus n. Now, do you need to write all this out in order to solve the problem? No, you just need it to be able to identify this statement here, right? In order to make the in order for us to go through the next steps. You don't need to go through what I just went through here, but again, this is the argument for why the next steps are going to be true. So if that's the case, then 26 here, or actually DE, will be parallel to BC, because you can view this as, you can view triangle ABC as a dilation of triangle ADE over point A, okay? And if that's the case, then again, DE is going to be parallel to BC. Angle C there, which measures 26 degrees, this is also going to be 26 degrees. Angle DEA is going to be 26 degrees. And if I know that that's 26 degrees, then I can figure out what is angle ADE, this angle here. Whoops. This angle here. And that would be supplementary to 82 and 26. So if I add 82 and 26 together, I would get 108, and subtract that from 180, I would get 72 degrees. And since angle BDF and FDE are all the same, I'm going to call these angles here x. So then I can say, so since x, and 72 are all collinear, I can then say x plus 72 is equal to 180. I can subtract both sides by 72 and add 2x. I will then end up with 108. And divide both sides by 2, I will end up with 54 as angle x. However, it doesn't end there, because we need to figure out what this angle over here is, which I'm going to call y. This angle over here, my apologies for that. So this angle over here I'm going to call angle y. So I now know angle x to be 54, right? So I'm going to label that in here. So this is really 54. And if you look at the overall triangle, triangle ABC that is, okay, I know angle A is 82, angle C is 26. This angle over here, okay, is going to be, again, supplementary to 82 and 26. Or alternatively, you can also think of this angle being corresponding to angle 72 there, right? Because, again, DE and BC are parallel. So now that I know angle B to be 72, and I have 54 degrees there, I can now solve for y. So I can say 72 plus 54 plus y is equal to 180. I'm going to add together the 72 and the 54, and I get 126. If I subtract 126 from both sides, what will I end up with? I will end up with 54. Y will equal to 54 degrees. So which answer choice is that? That's answer choice number 2.